Hi everyone, new episode. Took a bit longer than usual. Fortunately, I've been ill for a week or so, but I'm recovering a lot and it's time to record. So let's get started. Let's see where we left off last time. Do a quick build and run. As you might remember, we have our knight that can now follow a path. Um, look at them go. But they always keep facing the same direction. And it would make a lot more sense if, while following the path, also the facing of the character would change. So that's our objective for today. Before we dive into that, there is one part of cleaning up I want to do, and that is take out this rotation enum. That's now part of this ISO converter, and I think it should have its own file, just like the vectors, especially as we're going to add more stuff to this. We could do this during the episode as we move along, but it is probably a bit easier to follow if we just do it right now. And in a way, I think we should have done this already. So let's create a new file called rotation. Take the enum out, copy all the stuff in. So this should still build fine. We can now also create a quick test file, rotation test, import XC-test, and testable import tutorial, a final class rotation test as an XC-test case. Because in ISO tutorial tests, there are actually a couple of tests that deal with rotation directly, and it's these ones. The test rotation with reference rotation based on default rotation always returns existing rotation. So let's take this one out and move here. And also rename it a bit because the rotation is now redundant because we know already in rotation test. And same for the next one, that is the test rotation with reference rotation takes reference rotation into account. So let's see if our tests still pass. Okay, that's still working fine. So let's start working on facing. Last episode we created a function create follow path animation for entity, and we're going to augment this one by making sure that the correct facing is chosen when the animation is determined here using the get animation for entity function. And to do that, what we need to do is we need to compare the coordinate in the path with the last coordinate that we know we passed. So let's take our simulator for a bit. Let's say we have this tile here. That's the next point on our path. We came from this one. Then we want to compare these two to determine a direction. And the easiest way to do that is to be able to subtract them. So let's do that. Make sure that we keep track of the last coordinate that we had. And we can start off by the entity's XY position, or the entity's position. And we only need 2D, the 2D variant. That's why I'm adding .xy. And then we can create a look direction, and that will be our coordinate. That's a new position minus the last coordinate. And after that, we can set last coordinate to coordinate. So we're saving that one for the next one. Unfortunately, we haven't implemented the minus operator for 2D vectors yet. Can do that very quickly. Basically use the same template as the addition let's just change the operators around. And we now have a look direction. And this is a vector of either length 1, because these are always coordinates next to each other, or 0 if it's the same coordinate. Now we need to somehow change this into a rotation. And we don't have anything yet to change vector or direction into a rotation. So what we need is a new function for our rotation that can take a direction and try and craft a rotation from it. So let's write a test for that. Create a new test. And let's make sure that we will call it from look rotation returns the correct rotation for Cartesian vectors of length 1. This is awfully specific, but there's a reason for that, because our first implementation only has to take neighbors into account instead of possibly tiles somewhere much further. And I don't want to get ahead of ourselves too much by implementing a way more robust vector to rotation converter. I just want to get what is needed to help in the current situation. However, it does mean that I need to make my test naming a bit more specific to make clear what this one tests, and also I guess what it doesn't. So let's create some test cases, and there will be 4. So this will be an array of tuples, and they will take in a look direction, that's a vector 2D, and they will have an expected, that's the result, that's a rotation, and this will be a rotation, and let's define some cases. So the first one is a vector 2D, and let's say we go up 1. That in our grid is going that direction, meaning that the expected look direction is 135 degrees. And there are actually only 4 cases. So there's also the 0, 1 case. That's our 45 degrees situation. There is the -1 case. So that's going down. That's the 315. And then the last one will be the 225 for the x -1 version. So we'll go through each test case in the test cases, and we will assert that our test case, the look direction, we will have a function on rotation called from a look direction. And this is where we pass in our look direction. We get back a test case expected. And of course, we get a complaint that this one doesn't exist yet. So let's just quickly make a stop for that. Let's go in, open a second window for our rotation, create a static function, and this returns a rotation. Now this thing should compile and the test should at least run. but of course fail as we're hard coding a return value in. Okay, so let's see. So, well, there's two things. Of course, what we can do is we can do a switch statement that takes in our direction and then returns some value. For instance, we can always return the default rotation if we and stay in the same situation. We can also say let's create a few cases. So first case is for the basically the same cases. Let's see, we have a 0 on 1, and then we return 45 degrees. And this one is up. We can go to -1, 0, that's 225. And the final one is 0, -1. And this should be 315. And this one needs a type. Okay, let's see. So this test now passes. Awesome. But there's one thing that is kind of bugging me, because what would the rotation be that you get back if you add a factor in with a length of 0? So that one doesn't have a rotation by definition. Here we return default rotation in that case, but I don't think that makes a lot of sense. So I think it's more obvious that if from look rotation returns a nil for when vector of 0 length is passed in. So we can just assert a nil for rotation. On look rotation for 0. And this will probably complain because this can never be nil, although I guess the compiler doesn't notice yet, but at least we have a failing test because we're getting an actual value back. So this one should return optional, and then we can return nil as a value if we don't know what the value should be. So now these tests pass as well. Okay, cool. Let's use this one in our game scene. So we have this function here where we create a look direction. Let's say we have a new rotation, and that is rotation. Can get rid of this one, I guess. Rotation from look rotation, and then pass in this one. We now have a new rotation, and we can say our entity rotation equals new rotation. Oh, this is an optional. Let's say that if we don't get rotation back, we don't change the entity's rotation. We use the one it already has. So let's see if this helps us a bit. So let's rotate the playfield. Here's our knight. Let's move along a bit. Look at them go. Okay. Look, they're now actually facing the direction they're moving in. So that's kind of neat. But there is one thing that doesn't sit very well with me, because we are here changing the state of the entity actually for one reason only, to get the correct animation, because that's extracted in the get animation for entity function. And if setting the rotation would have any side effects other than being stored as a rotation, those would all get triggered. There aren't any here, but still, this feels like something that you might bump into further down the line that trips you up. So to prevent that, what I want to do is I want to create basically make sure that I don't change our entity to get an animation. And I want to do that by using something, a sort of stunt double. So what I would like to do is to create a new entity. I call it stunt double. That will be an entity, copy of an entity. Just comment this one out because it won't compile. Basically, what I want to do is be able to create a copy of an entity. And what is a copy of an entity? Well, it's defined by two things. A copy is a separate instance, but it has all the same property values as the original one. So let's create that something to do that. And first, to do so, let's create a file to store entity test. We'll probably have more in the future anyway. Import exit test and import our ISO tutorial. And I call this the copy constructor. I think this is the general term used in other programming languages as well. Note that this is only necessary if you want to make copies of instances of classes. A struct already always copies, and an enum copies as well. So let's look at our two requirements. So our first requirement is that our copy returns a new instance. So let's create an entity. Can have a sprite name and a position somewhere. Let's create a copy. This one I won't compile yet. And then I want to assert that our entity is not equal to our copy. But please notice that the specific operator here is the inverse of this one, the 3 equal sign. We're not checking if they have the same values here, we're checking if they are the same instance. I think under the hood it basically checks if it's the same memory address that's being referenced. So if this if this expression evaluates to true, then we know that they are not the same. So let's have a look. So let's start implementing our copy. This creates a new entity, and let's really be lazy. Let's just return ourselves and see what happens. So let's run the test. This test now fails because they are indeed exactly the same. So no problem. Let's be really let's be a bit more reasonable then, and use our composition and use our own sprite. Let's create and return a new entity. Okay, so the first test now passes. Time for the second one, because this one only checks if they are different. And we want to check if they have indeed the same properties. So the copy returns an instance with same properties as the original. So we create an entity, and let's make sure that we have a really random name, a UUID string. And let's use a random position. And as a rotation, let's use a rotation that's not the default rotation, but some other rotation. So let's create a copy. And then let's assert that our copy sprite is the same as our entity.sprite. And for position and for rotation. Because these are the only properties that are still being stored in our entity. Now, there is a risk of these tests that if you add an additional property, if you don't add it to the test as well, you won't be testing whether you're actually taking it into account when creating the copy. But I'm not sure if there's a way in Swift to do this in a more automated or way, using some form of mirroring or reflection. So this is what we're going to work with for now. So let's run this test. And of course, this one fails on the last one because we're never copying the rotation. So no problem. Let's take a copy. Let's set it to our own rotation and return the copy. And now we have a working copy constructor. Let's use it in our game scene. So let's start by creating a stunt double, and then just make sure that instead of setting the entity's rotation, we set the stunt double's rotation, and we should use the stunt double here. And I think that should be, we can even use it here if we creating the double is the first thing to do. So basically our knight is using a stunt double for all the hard work of walking around the battlefield. Okay, this is how far I wanted to get for today. What we can notice, of course, is that knight still, each time we create a new path, still starts at the same position. And the reason is that although we are playing in animation, we're never really updating the knight's internal state to reflect the fact that this action was taken. This is what I want to get started working on next time. So thanks for watching and have a good day.